Hello. In this section, 8.3, we're going to be looking at inverse trig functions. So for a function to have an inverse, it has to be one-to-one. And since sine and cosine are not naturally one-to-one because they don't pass the horizontal line test, we're forced to make them one-to-one by restricting their domain. So that's what we're going to do here. We're going to restrict the domain of both sine and cosine to be a specific interval so that it becomes a one-to-one function. Okay, so the notation that they use for inverses will be this here, sine to the negative 1x. That means inverse. It doesn't mean reciprocal. The other notation that's also used is arc sine or arc cosine. So an inverse is basically reversing the x and y's. So the domain of the sine function will now become the range of the inverse, and the range of the sine function will now become the domain of the inverse. So in other words, we're swapping ranges and domains of sine to their inverse. Okay, so the domain of sine inverse will now become negative 1, comma, positive 1 instead of it being the range. And the range of the inverse will become the restricted domain, which is negative 1/2 to positive 1/2. For cosine, it's similar, but instead, the domain is still the same, negative 1 to 1, but the range, we're going to define that from, or restrict the domain, or the range for the inverse to be 0 to pi. And for tangent is very similar to sine in the sense that the domain will be restricted to negative pi over 2 to pi over 2, but the difference is that not inclusive of those endpoints. So the domain is going to be, for this one, is negative infinity to positive infinity by the nature of the tangent function, yet the range will be the restricted domain of the tangent function, which is there. And here's a visual representation of the inverse, the sine and the inverse, the arc sine or the inverse sine, however you would like to say that. It's right here. So the graph here, this blue graph, is the sine function. And if you reflect that over the y equals x line, it becomes the inverse. So this green graph is the inverse sine. And this dark blue is the cosine function. If you reflect that over the y equals x line, you will see that this becomes the inverse. And the tangent looks like this. The blue graph is your tangent function. And if you reflect that, the inverse becomes this green aqua looking graph here. Okay, let's move on to the next page. So here we're going to evaluate trig functions. So what we need to remember is that for sine, the domain of sine is restricted to negative pi over 2 to positive pi over 2. So that's where our sine values should fall in. So for this example here, sine inverse of negative 1/2 of positive 1/2, what we're looking for is the angle. Whenever you're asked to find an inverse, what you're looking for is the angle that corresponds to 1/2 as a sine value. So since sine is a y coordinate, we're looking for which angle on this right side of this unit circle has a sine coordinate, or I'm sorry, a y coordinate of 1/2. And it turns out to be right here, and it's 30 degrees or pi over 6, whichever you would like to use is fine. But typically, in most cases, they want radians, so I'm just going to go with radians. So in this case, the answer is pi over 6. All right, once again, the reason is because you're looking for the angle on this side of the circle that has a sine value of 1/2, and that is right here. The sine value is a y coordinate, and so it would be 30 degrees or pi over 6. So that is our answer there. For the next problem, it's an inverse cosine problem. So in this case, we're going to switch, instead of the shading being the right side of the circle, if you recall, it's for cosine inverse, it's defined to be the upper half from 0 to pi. So I'm going to highlight that instead for problem number 2, or part B. So this is where cosine inverse is defined from 0 to pi. So we're looking for the angle which has a cosine value of negative radical 2 over 2. If you're looking at the upper half of the unit circle, you would see that that would be the x-coordinate. So that would be this angle 135, which is also written in radian form as 3 pi over 4. So let's write it in radians. 3/4 pi. And like I mentioned, you can also use degrees if you'd like, unless the problem specifically asks for one or the other. Okay, let's go ahead and move on to tangent. So of the three, tangent is a little bit, or is the most challenging in the sense that, because if you recall, the definition of tangent is going to be y over x. So we're looking for the ratio of numbers who has a ratio of y divided by x of -1. And just as sine was defined on the right side of the unit circle, so is cosine. So I'm going to go back to shading the right side of the circle because that's where cosine inverse is defined. And now we can find which of these, well, since the value is a negative value, we know tangent is not negative in quadrant number 1 because both x and y are positive. So the angle must be somewhere in quadrant number 4, because if you look at the ratio between y over x, you will see that it will be negative because you have a negative divided by a positive. The question then becomes, which of these three angles has a ratio y divided by x of -1? In this case, it's clear that it's going to be this angle here, 315, because it's the same number or their opposite values. So any number divided by itself is 1, which means that any negative number divided by its positive version would be -1. So therefore the answer must be 7/4 pi. However, 7/4 pi is not in the domain of the inverse function. Remember, we must be in the domain of negative pi over 2, positive pi over 2. And since 7/4 pi would require us to go outside of the domain, instead of going in the positive direction, starting at 0, you're going to go in the negative direction. So you got to find the reference angle. Well, and so the reference angle is just going to be this angle right here. So the angle is, since it's going in the negative direction, would be negative pi over 4. Because it has the same value as the 45-degree one, other than it being negative instead of positive. So instead of going to positive pi over 4, or instead of going all the way around, you're not allowed to do that. You can either just go up to here or down to here, and we're going down to here, which would be negative pi over 4. So that is our final answer. Okay, so that's the thing that you need to be careful with, is especially for sine and tangent, you gotta be aware that you may possibly have to go into the negatives if you're going into the fourth quadrant, because you're not allowed to go outside of the domain to go to the fourth quadrant. Okay, so let's go ahead and move on to the next part of our notes. Okay, so in this case, now they are asking for us to use our calculators to evaluate cosine inverse of negative 0.4 in radians. So this is just a calculator problem. So just make sure that your calculators are in radian mode first, and then hit the second cosine button to get to the inverse, and then type in -0.4, and you should get the value. I've already done this on my end, on my calculator, and I ended up with 1.1593. So go ahead and try that and see if you're getting the same value that I'm getting. If you're not, you may be in degree mode, and that would be the reason. Okay, so in some cases you are going to have to do something different, as you will see in the next slide and the next page of our notes. Unit circle. Let's go to this unit circle here. You will see 2/3 sine. 2/3 sine is right here. 2/3 pi. The sine is radical 3 over 2. So you want to go to the right side of the circle because that's where the inverse sine is defined, and look for the sine value that has the angle that has the same sine value as square root of 3 over 2, and it'll be this one right here. This angle is in the correct domain, and it has the same sine value as 2/3 pi. And so the answer is pi over 3. Circle. I'm going to erase this part since that's not where inverse cosine is defined. Inverse cosine is defined from 0 to pi. Okay, so let's see. We're looking at negative pi over 3, right? So negative pi over 3 is, this is positive pi over 3. So that means negative pi over 3 is this one. So this angle, cosine has a value of 1/2. So now you go up to the upper half and look at what angle has a cosine value of positive 1/2. And it turns out to be this angle, which is pi over 3. Essentially, it's just a reference angle. So that's what it comes down to. It just comes down to finding the reference angle. So it is. So for example, here they're asking us to find the measure of the theta of the angle. So in order to find that, we got to determine which trig function is appropriate. In this case, it's going to be sine. So sine of theta is equal to the opposite, which is 6, over the hypotenuse, which is 10. And now, since we're solving for theta, you have to take the inverse of both sides of the equation. So when you take the inverse of both sides of the equation, you end up getting theta equals inverse sine of the ratio 6/10. So you see how that works? You're taking the inverse sine of both sides here. If you take the inverse of the left side of the equation, you're going to just get theta, because sine and inverse sine essentially cancel each other out. And when you take the inverse sine of the right side, you get this expression here. So now we just use our calculators, and if you use your calculator, you will get, for these type of problems, I recommend degrees. If they don't specify, then you should always use degrees for these problems. When they give you a triangle and they're asking for an angle, if they don't specify degree or radians, I recommend degrees. So make sure your calculators are back in degree mode, and you should end up getting 36.9 is what I got on my calculator if I round it to 1 decimal place. Okay, so let's look at taking the inverse of a sine function or the inverse of a cosine function. So here is what they show us. They say that in many cases, if you take the sine of an inverse sine, then it's just going to be whatever the x value is, and similar with the rest of the functions. But that's only if x is in the domain of that specific inverse function. So let's see how it works. Let's go down to this example. So for example, first thing you want to notice is that you're taking the inverse cosine of a cosine. So they should, in theory, cancel out, and it should be just the angle, right? And in some cases it will be. You just got to double check that 2 pi over 3 is in the domain of cosine. And what is the domain of cosine inverse? Well, I'll write it for you. It's got to be within 0 to pi for inverse cosine, which it is. 2/3 pi is in the upper half of the circle. So in this case, it is true. These do cancel out, and you just end up with 2/3 pi. All right, in the next case, let's see if it's true for the next one. In this case, recall that the domain for the inverse sine function is negative pi over 2 to positive pi over 2. And you will see that 2/3 pi is not in the domain. So what you have to do is you do have to find the angle that has the same sine value as sine of 2/3 pi. So if you go back to the, so in this case, it's not so simple. You can't just cancel out the inverse sine and say, oh, the answer is 2/3 pi, because that's incorrect, because it's not in the domain. So this is the correct answer. Hopefully that made sense. All right, let's look at the final problem here. So once again, I'm just going to restate the domain of the cosine inverse function is 0 to pi. And as you can see, negative pi over 3 is not in this domain. So same thing that we did over here, we're going to have to do over here. So let's go back to the unit circle. Let's find out what the cosine of negative pi over 3 is, and then we'll find the angle in this domain that has the same cosine value as that. So let's go back to our positive pi over 3 would be the final answer for this. Okay, that is it for that. Let's see what else we have on the next page. Okay, so for this, sometimes you will get expressions such as this, inverse tan of 7 over 4, but these aren't angles or ratios that show up on our unit circle in standard position. So instead, what we have to do is we have to draw a triangle in the proper quadrant, and then we can evaluate the sine of this angle once we've drawn the triangle. So let me show you how this works. So we're going to go ahead and draw our triangle. Let's first draw the coordinate plane. Okay, and since, remember, tangent inverse is defined from negative pi over 2 to positive pi over 2, so the right side of the unit circle. But this is a positive ratio, it's not negative, so therefore it's going to be in quadrant 1. If this had been a negative, we would have done it in quadrant 4 because tangent is negative in quadrant 4, but this is positive, so we need to be in quadrant number 1. So draw a right triangle. You can give the angle any name. I'm going to call it theta. So essentially what this becomes is sine theta, because theta, we're defining it to be tan inverse of 7/4. All right, so now let's label our triangle. Tangent is opposite over adjacent, so opposite is 7, adjacent is 4. Doing the Pythagorean theorem to get the hypotenuse will give you the square root of 65. You can go ahead and confirm that that is indeed what it should be. If you want to pause the video, you can. Okay, and now that you have the missing side, now you can find the sine of the angle. That's all you got to do. So once you've labeled the 3 sides, now you can finally find the sine of theta, because remember, we're calling this theta. You can give it any name. You can call it alpha, you can call it t, you can call it x. I like theta personally. So the sine of theta is going to be opposite over hypotenuse. 7 over rad 65. And remember, you do have to rationalize the denominator, so I'm just going to go ahead and rationalize this. You can confirm that this will be the rationalization of that expression. Okay, so moving on to the last one. This one is very similar. The only difference is that there's an x instead of an actual number. So there's a variable there. So let's start it the same way. Let's go ahead and draw our triangle. Whoops, that's not what I wanted to do. Draw our triangle. Okay, so this will also be in quadrant 1. All right, so let's go ahead, because x over 3 is positive. They do tell you that x is between negative 3 and 3. In this case, you can just assume that x over 3 will be a positive number. So therefore, we should draw the triangle in quadrant number 1 again, just like we did in the previous example. All right, call it theta if you'd like, just like I'm going to. So this expression will now become cosine of theta, since we are defining theta to be sine inverse of x over 3. Let's label the triangle. Sine is opposite over hypotenuse, so opposite over hypotenuse. If you do the Pythagorean theorem, once again, you will get the expression the square root of 9 minus x squared. I'll let you confirm that. If you'd like to pause the video and double check that, you can. Once you get that missing side, now you can finally find the trig function of the angle theta. So in this case, they're asking for cosine, so you're going to do adjacent over hypotenuse. So the final answer will be adjacent over hypotenuse. So it turns out to be an expression in terms of x. All right, and that concludes this section.